I'm Meenakshi from St.Josephs College of Arts and Science for Women, Ozur. I am Assistant Professor in Department of Mathematics. My topic is complex analysis. In that complex analysis, we see the Cauchy Riemann equation. It is very important theorem in that particular topic, complex analysis. Okay, we see the statement. Suppose that f of z equal to u of x comma y plus I into v of x comma y, and that f dash of z exists at a point z naught, where z naught equal to x naught plus I into y naught, then the first order partial derivatives of u and v must exist at x naught comma y naught, and they must satisfy Cauchy Riemann equation ux equal to vy, uy equal to minus vx. Also, f of z can be written as ux plus I into vx, where these partial derivatives are to be evaluated at x naught comma y naught. So this is the statement. In that statement, given function f of z equal to u of x comma y plus I into v of x comma y is given. That is, this is the given function. In that function, derivative exists. That is, f dash of z exists at a particular point z naught. That particular point z naught is complex number, so is it not equal to x naught plus I into y naught? Then what is we prove? Their first order partial derivative u exist. That is, u partial derivatives means ux and uy. V partial derivatives are vx and vy or exist. Then we prove the Cauchy Riemann equation. This is ux equal to vy, uy equal to minus vx. Also, f of z can be written as in the partial derivative form is ux plus I into vx. Okay, so we see the proof of the theorem. So what is differentiation? First, we know what is differentiation definition in the complex analysis. So differentiation means f is differentiation of that function f means f dash. That is, f dash of z equal to d by dz of f of z. Here given f of z is u plus I into v. Okay, to prove ux equal to vy, uy equal to minus vx. Okay, assume that here f dash of z exists. By the definition of differentiable, f dash of z naught means that is limit del z tends to 0, mod f of z naught plus del z minus f of z naught divided by del z. That is means numerator is taken as del w, denominator given del z. So this is taken as equation number 1, where del w is numerator part. Given that f is equal to u plus iv in the order per x comma y. Del w means, so we see del w means f of z naught plus del z means in that f having u and v. So u of x naught plus del x comma y naught plus del y plus I into v of x naught plus del x comma y naught plus del y minus here f of z naught, so that u of x naught comma y naught plus I into v of x naught comma y naught. Next, del w means that is u of x naught plus del x. So this is the format. So real part separately taking and imaginary part combined. Okay. Next we see the f dash of z. So f dash of z means numerator part is del w, no? So del w is previous part we have del w. So numerator is del w value. Denominator is del z. Del z means del x plus I into del y. Okay. Next, f dash of z, we taking this is taken as limit in that del z having del x and del y, So limit del x comma del y tends to 0 comma 0, real part of del w divided by del z plus limit del x comma del y tends to 0 comma 0. This is imaginary part of del w. Okay, let del x comma del y equal to taken as in that del x comma del y, first we taken as del y equal to 0. So f dash of z equal to del w divided by del z. We know that. So in that part, you are taking as del y equal to 0. So in that equation, del w equal to 0 means del y equal to 0 means we get this part only. So whatever wherever del y presenting, that value is taken as 0. That's all. So u of x naught plus del x comma y naught minus u of x naught comma y naught plus I into v of x naught plus del x comma y naught minus v of x naught comma y naught, the whole thing divided by del x. Okay, next we see the limit del x tends to 0. So limit, so in that particular point, so you real part whatever having, imaginary part whatever having, separately taking. So so that f dash of z not equal to ux of x naught comma y naught plus I into vx of x naught comma y naught. Okay, next part we taken as del x tends to 0. So next we taking del x tends to 0. First we taking del y tends to 0, del x separately constant. Next we takes del y is constant, del x taking as 0. So in that f dash of z numerator part, whatever wherever presenting del x, that particular value taking as 0. Then we have, so limit del y tends to 0, u of x naught comma y naught plus del y minus u of x naught comma y naught plus I into v of x naught comma y naught plus del y minus v of x naught comma y naught. Whole thing divided by denominator is del x tends to 0 means I into del y only. Okay, next separately taking. So real part is divided by denominator part, then imaginary part is whole thing divided by the denominator part. Okay, so next we have f dash of z naught equal to I into uy of x naught comma y naught plus vy of x naught comma y naught. Hence f dash of z naught equal to we getting a vy of x naught comma y naught minus I into vuy of x naught comma y naught. So this equation taking as fifth equation, equating 4 and 5. Fourth equations means we have that del y tends to 0. After that del y tends to 0, we getting particular equation. That equation is called fourth equation. This equation is called a fifth equation, equating real part and imaginary part. So first of all, equating real part means ux of x naught comma y naught equal to vy of x naught comma y naught. Then imaginary part is equating means vx of x naught comma y naught equal to minus uy of x naught comma y naught, so that ux of uy of x naught comma y naught equal to minus vx of x naught comma y naught. Okay, so this is the proof, that is ux equal to vy, uy equal to minus vx. So in that equation f dash of z means ux plus I into vx. Thank you everyone.